Welcome everybody to geohug. So before we do kick off today's session, I would like to take this time to acknowledge the traditional lands which we're all coming from. I live on the beautiful lands of the Gadigal of the people of the Aurora Nation, and I'd like to pay my respects to the elders past, present, and future. And yes, I am thrilled that we have Amy Mayer joining us today. So Amy is currently a senior resource geo at MEC Mining with more than 15 years of industry experience in mining, resource development, and data science consultancy. And it is going to be brilliant learning from her as she demystifies AI and data science and explores how this new technology can transform the way that we work in geoscience and mining. And she'll also be giving us some practical guidance on how to get started, along with some tips for effectively applying these tools. So this is going to be a really good session, and it's going to be a bit different. This one is interview style. So I'm going to start promoting you all as panelists. Please don't be shy. Come on through, get the cameras on, get the mics on. I've got a short list here of questions to get the discussion started, but then we'll be opening it up. So we want to hear from you. So please get your questions ready. And yeah, hopefully we can have some really good chats very shortly. But yes, thank you so much, Amy, for being here. I'm just thrilled having you here today.
No, thank you for having me. I really appreciate the opportunity.
It's brilliant. Before we do get into data and AI, I was wanting to know what got you into geology to begin with.
I was very lucky that as a child I grew up in Hawaii, and I lived there for a few years. So obviously with the volcanoes and things over there, it was really just
That's
that.
amazing.
We used to kind of go and check out the volcano at weekends and things and poke lava. So yeah, no, that's pretty much where it all started.
Oh my gosh. And I can't believe I never would have left Hawaii. Why did
I
you
know, I've never really quite forgiven my parents for bringing me to the UK. So
Yeah, that's a tough one. I would have just stayed there. That is brilliant though. And so yeah, I imagine there's been a lot of travel and highlights in your career so far. What are some big standouts for you?
Yeah, so yeah, the travel is definitely one of them. And after I finished studying geology at uni, I did go back out to Hawaii and I spent a bit of time there doing a volunteer role with the USGS at the Hawaiian Volcano Observatory. And that was really, I mean, I can't believe people actually get paid to do that kind of work. It was just awesome. Just,
That is
yeah.
brilliant.
Yeah, and in fact, actually, I think it's yesterday, the eruptions just started again. It's in quite a remote area of the island, but yeah, things are happening again. So yeah,
Oh,
that's pretty cool.
so you'll be watching that one closely, I'm sure.
Yes, definitely. Yeah.
That is brilliant. And I was curious, I get everyone to bring some of their favorite pet rocks along. And I have a feeling from memory when we chatted earlier this week that maybe one of yours is related to Hawaii. Was that
It
right?
is, yes,
Yeah.
yep. So I've got it right here. So it's a type of rock called reticulite. Let me see if I can get it.
Oh,
Hopefully
wow.
the focus is good enough on the screen there. It's a really interesting type of rock, I think, because it's basically solidified foam from a fire fountain that comes out of particularly Hawaiian volcanoes. So this example here is from the 1969 eruption of Mauna Ulu. And basically these things are it's one up from pumice. It's like a pumice, but the next level up because there's just so many holes in it. It doesn't even float. So all of those little bubbles that hopefully you can see, they've all fused together and all the bubble walls have popped. So if you put it in water, it just sinks straight through to the bottom. So it's like
Wow.
98% vesicles or something like that. So yeah, super light, very delicate. In fact, even just holding it here, I'm now getting all little bits of rock stuck in my keyboard. So I might pop that down.
That is very cool. Thank you for sharing that one with us. That's brilliant. And yeah, thank you, yeah, so much again for joining. We'll get stuck into it now. So to kick it started, what is data science and how is it related to AI?
Yeah, so yeah, this is good because it would be good to clear up a few terminology type things because you hear these words bandied around all the time and then you don't necessarily know exactly what they mean, and also some of the definitions are a little bit subjective too, so depending on where you Google or who you ask, people will tell you different things. But broadly, as I see it, data science is the field of study, and it's about just uncovering insights from data, basically. It's a multidisciplinary field, so it brings together bits of mathematics, bits of computer science, data engineering, all of these things sort of pushed together in one discipline. But it also incorporates AI as well, as part of that. And AI is really like a general term for when machines or computers perform functions that we'd normally associate with human intelligence. And then within that, you also hear the term machine learning. And machine learning is kind of like the toolbox for achieving the end of AI. So machine learning is more like the actual algorithms and functions that you use to perform the AI. So that's kind of like how it sits. It's almost like, data science is the broad field, and then you've got AI within that, and machine learning, which is sort of how you actually apply those things. And another term that people probably heard of that gets talked about all the time is neural networks and deep learning. So those are a type of machine learning algorithm, and they're essentially, it is really a network of lots of little tiny mathematical equations that individually are quite simple, and they're all just linked together in a network, basically. And the deep learning comes from when you stack lots of those networks on top of each other. So the opposite of that is actually shallow learning. So if you've got 1 or 2 layers in a network, it's shallow learning, but you normally hear people talk more about deep learning.
Yeah.
But yeah, an interesting thing is that I think is that it's actually all really been around since kind of the 1950s. It's been around for decades, this actual sort of theoretical technology. And we've seen this apparent explosion in recent years, and it has exploded. Certainly, it's a really fast moving field, but at the same time, a lot of that theoretical knowledge had already been developed. And it's only recently that we've had the computing power that's been able to actually, apply these things and use them. So yeah, that's sort of where you see that slight disconnect between, what you think, and then all of this stuff that's suddenly happening and out in the public domain.
Yeah. Yeah. Okay. And what would be the advantages of AI?
So I think the main advantage is the fact that it is able to do things that a human being just cannot do individually. It can uncover insights in data that a human being, even if they had an entire lifetime, couldn't possibly perform all of those different individual calculations and things like that. So it can kind of act as a bit of a crystal ball as well. If you go down into the field of sort of predictive analytics type approaches, you can predict outcomes based on data that you've got, which is obviously super useful. And that kind of links into this speed as well, like we can process these algorithms on, like I was talking about, the compute power that we've got now, so that we can actually use them in earnest and get some really good insights coming out of it. Also, I think it's quite versatile in terms of applications to particularly any kind of business or any project life cycle. You can apply it to anything from HR type stuff, which is a company I worked for previously. They were looking into that to sort of analyze staff and predict staff retention and things, all the way through to sort of traditional, more kind of mathematical functions and stuff like that. Yeah. And I think something else that's quite cool about it is the fact that you've got all of these different types of machine learning models, but you can actually apply them to lots of different things, even though it's essentially the same algorithm. So for example, you've got this type of neural network called a convolutional neural network, and they're traditionally used quite a lot in image recognition, image processing. And it looks at all of the pixels in the image, and it kind of identifies the difference on the really small scale between those pixels to do that recognition. But you can use that exact same algorithm for something like natural language processing, which is the technology behind ChatGPT. And in that respect, it will take the words in a sentence and it will kind of structure them like a grid. It's what's called vectorizing them. And it will basically look at that almost the same way as it would look at an image, these sort of pixel differences. It will look at word differences. And I just think that's really cool that you've got this toolbox that you can apply to lots of different things, really. And then along with that, all of this stuff is scripted. So that script itself can act as like an audit trail. You can reproduce stuff over and over again, get the same outcome, remove that kind of human error associated with if you were doing things manually. And you can get tangible statistics on an outcome of accuracy or time saving and things like that, which is really useful when you're trying to quantify the value of using it.
Yeah. Oh my God. And what about the disadvantages then?
Yes, of course, because like with anything,
The pros and cons of it all,
there's
yes.
always a con. Yeah. um, I think one of the things is the kind of investment that you need in time and resources. Um, by its nature, data science is very much exploratory. So there's not necessarily a guarantee of success. You know, you sort of see in the public domain all of these cool things it can do, but you don't see the hard work and the experimentation and the times that it hasn't worked that sort of led up to that point. And I think kind of doing that and managing those expectations is sometimes quite difficult. You know, a lot of people think that AI is like a magic wand, and it is. It's really cool. It's really awesome, but it's very much not a one size fits all approach. There's a lot of work that goes into the back of that, and you might not have access to some of those resources as well. You know, you might be able to create some amazing machine learning algorithm, but you just cannot run it on your own laptop. You just haven't got the compute. So there's sort of challenges there as well. And I think the data quality too can be a bit of a problem, especially when, if I bring this back to more related to geoscience type applications, you know, the data that we have in geoscience is sometimes quite sparse or has inherent variability in it, or it can be quite subjective if you think about logging data. And that can lead to bias and things, which is then obviously carried forward into your models. Your modeling and your predictions are only going to be as good as the data that they're based on. And then also you have this element of mistrust, I think, too, that it's seen very much as a black box type approach, which in many ways it is. You know, like neural networks, a human being can't just see those kind of relationships in data, but then that builds in a level of mistrust to it that you have to try and justify to people. Especially as well when you hear in the media all this thing about AI taking over the world and stuff, you know, that kind of bad press doesn't really help either.
No. And speaking of taking over the world, there is often the comment of it's going to put people out of work. Will it be taking any roles in the mining industry?
So I think personally it's going to change how we do things and not what we do. I mean, it's inevitable. We're seeing it happening already, that people are adopting it, and it's here. But I don't think it's necessarily going to put people out of jobs. It's just going to be, we're going to have to think of different ways of doing things and upskill as well. And I also think that having that domain knowledge is really, really vital, because you can be the best data scientist in the world, but if you don't understand what you're applying your tools to, you're never going to get a decent outcome. And I've experienced this firsthand. So my previous role was just pure data scientist. I wasn't doing anything to do with geoscience at all. And I was working for it was quite a large engineering consultancy in the UK. And we were looking at some algorithms to predict flooding in rivers and also within sewer networks and things like that. And I'm by no means a water engineer. I had no knowledge of that kind of side of things. But my job was the data scientist to create these algorithms, make these predictions. And so I spent a lot of time talking to one of the water engineers who explained a lot of context and background information about how pumps work in these scenarios and these different patterns we might see in data and stuff like that. I learned more about sewers than I would ever wish to know. But without that information, there's no possible way I could have built an effective model, because as soon as he told me these things and I was able to actually, you know, manifest that in the code and do some feature engineering and things like that, we immediately, the accuracy of our predictions just went up because of building that in. So it's really, really important to have that domain knowledge, and I don't think that will ever be lost. So that's definitely something to remember.
Yeah. So speaking of all the different models and your experience in working with it, what are some examples that you've seen of how mining and exploration companies are using it? I know there's already a question here specifically on the exploration front, because it is quite a traditional kind of field of study. People are really keen to hear how exploration in particular is using AI.
Yeah, sure. Yeah. So, yeah, I mean, you can apply it to, I think I mentioned before, these different stages of project life cycles, and that's no different when it comes to geoscience and mining. So from an exploration point of view, one of the things that I've seen is like processing satellite imagery and data for things like target generation. I don't know a huge amount about it specifically, but I know it's being done out there. And in my previous role, it wasn't obviously for geoscience related stuff, but I did work with a lot of satellite data and imagery when we were looking at sort of biodiversity kind of applications. And yeah, the machine learning algorithms that you can use to sort of do target generation and stuff from that imagery is definitely one area that I think exploration can make use of it. You've also got things, further along down the sort of mining chain, like I know Orica, for example, have got a tool which sort of does measuring whilst drilling. I can't remember the exact name of the tool off the top of my head, but they're looking at sort of collecting data whilst drilling is happening to make predictions on things like rock types and stuff like that. One of the other tools that I've had quite a bit of fun playing with is Micromine CoPilot. And again, like a lot of companies out there are doing similar types of things. So I'm just talking about the ones that I've had experience of. But CoPilot is like a neural network tool for creating a block model and populating it with grade predictions, but very much in a non-traditional way. So yeah, using a neural network rather than traditional resource estimation approaches. And it's just super cool for being able to give you like a baseline model and guide your predictions. I mean, they certainly, Micromine themselves don't say it's a replacement for a traditional model, but it's just a really good baseline. And I know that I went to a talk recently where there was a company there, I think it was Harmony Gold, the geologist was talking about having used this tool to successfully identify new areas of mineralization. So they ran the tool and compared it to their existing model, and they found some new places where it looked like there might be some more more mineralization, and they went and explored there, and it was indeed there. So it kind of helped them find some new areas.
Yeah.
Okay, that's a really good question,
Yeah.
actually. Yeah. Well, where do I start? One of the things is the fact that you can do all of this experimentation and kind of prove that you can build these kind of models, but to actually use them, you need to be able to what's called deploy them. So if, for example, I go back to the example I was giving you before with the sort of specialist domain knowledge with river and flood prediction, that was something that we had to have a client use and build like a tool, a product essentially. And going from that proof of concept to actually then something that you can deploy that other people can use, that was another whole massive area of work, and having another whole team of people, of software engineers, cloud engineers, front end web designers, all of that kind of stuff. So I think one of those challenges is, and I mean, it did work eventually, but it was definitely not without lots of iteration, is trying to get over that hurdle of going from something that you've proven a concept of to something that you can actually use in earnest. Yeah, I don't know if that answers the question fully, but yeah, I'm happy to go back to that later if needs be.
Yeah, awesome. How important? Oh, sorry. Yes, Steve, jump in.
Yes. Hi, I'm Steve Sullivan. I think it's very
Hi,
important
Steve.
that we discuss things that don't work, because there's a lot of stories about things that do work, but I think we learn a lot of lessons in life about things that don't work. People have tried things and aren't successful, and that doesn't seem to get a lot of conference air time or airing at
It's
all.
so
So
true.
that's why I asked the
Yeah.
question.
No, that's a really good question. And I sort of, I suppose, alluded to that a little bit earlier when I was saying about you don't see the hard work that goes in behind and the number of times something's failed, or even that experimentation of and I think a lot of people also go straight to something like a neural network when they're thinking about AI, because they're like, that's the really cool, super complicated, interesting thing. But actually sometimes just testing lots of models is a requirement to get to that point of knowing which is the best one. And so that project I was talking about with the flood prediction, we tested a neural network model and it didn't work particularly well for our our situation and our data set. And in the end, we ended up using quite a basic linear regression model, but like an ensemble model where we've pieced together all these different bits and pieces to kind of make it a little bit more fancy, if you like. But it actually gave us a much better prediction. And so we spent a lot of time essentially failing with experimenting with models that we thought might work, that in the end just didn't. Yeah, went back to a much more baseline model, which gave us a much better output.
That's really cool. Thanks. And what are some of the hardest things about putting AI into practice in day-to-day work?
I would say probably the poor input data is a difficulty. I mean, as poor input is probably not the best way of phrasing it, because it's not necessarily bad data, but the amount of time that you have to spend on the data is a challenge, and can be a challenge depending on what that data is. Also trying to kind of convince people that AI isn't a magic wand, and explain how difficult it is sometimes to get to this end result. I mean, people look at something like ChatGPT, for example, which is just amazing, but that's taken a team of people years to, you know, to create lots of really, really brainy individuals, all working together. I mean, the thing's trained on basically the entire internet. So the amount of work that goes into something, which when you see the end result, you're like, oh, this is cool, is definitely difficult. And I think one of the other things, which is something I wanted to talk about more as well a little bit later, is kind of how you get into it. So, you know, having the time to play with these things is a real challenge, because quite often people just want the end result, or, you know, there's not necessarily that recognition of the work that's gone into it, and knowing where to start as well, like setting things up. So this is something that I think is often missing in a lot of courses that you can do. There's some really great courses of teaching you how to code and all of this kind of stuff, but quite often the bit that's missing is, how do you actually start setting that up? What software do you use? You know, how do you configure your laptop to work with that software? How do you set up a virtual environment to code within? All of these things are kind of practical side of things. I certainly found from my experience when I was learning was missing from a lot of these things. So sort of filling that black hole in your knowledge of maybe general computer science, if you don't come from a computer science background, can be a challenge. It's not just about the maths as well.
Yeah. Going on that, there has been a couple about the skills and career pathway kind of questions already coming through in that field. So I might go there now. So yeah, what sort of technical background makes a good data scientist?
So I think having a really good attention to detail, to be honest, is probably the main one, and being able to think quite logically, and just laying everything out. What exactly is the thing you're trying to achieve, and just mapping out how you're going to achieve that. I think it's unavoidable as well that you really do need to learn how to code. I mean, my background is geology originally, and then I moved to the UK and I went and did a master's in data science, and I was there with a load of people who'd done their undergrads in maths and computer science, and you know, everyone's going around going, oh, what's your background, etc., etc. And I was like, oh, I'm a geologist, and everyone's just like, what's that? So a lot of them already kind of had half that experience, either the math side or the computer science side. So I can certainly relate to people who are learning. It is a challenge, especially a little bit later in life, trying to learn what is essentially a new language. But it's really worth it, and I think it's unavoidable. That's something that you kind of need to do. And I would also say, start, if you really are starting out and you've not done any coding before, pick one and go with it. And then I suppose the next question is like, well, which one do you pick? And that's very much like all of these things. People get very familiar with one tool that they use and they say that that's the best one. My personal opinion is something like Python, because there's so much sort of material out there to help you learn on the internet. There's so much accessible stuff, you know, and it's really widely used, and it's really good for data science. It's got visualization libraries as well as all the machine learning kind of stuff built in as well. So yeah, I don't know if I've kind of drifted a little bit off topic there, but hopefully that's
That is
that's
good.
helpful.
We do have someone here that has come from the other side. So they're a master's student in AI and maths with no background in mining, but they will begin their PhD in mining reconciliation in a few days. Do you
Okay.
have any advice for them?
I would
They're
probably
coming
say,
from the other end of the spectrum.
yeah, that's interesting. Yeah.
Yeah.
I would probably say talk to as many people as you can who have that experience. Just ask them to share their experience, sort of things that have worked for them. And I mean, so because obviously that's the different side to what I was coming from, but looking at it from the side that I came from, I found that YouTube was a really helpful resource.
Yeah,
Just
okay.
like, especially if there's something that you maybe don't particularly understand about something, you can often find, I know like Stanford University, for example, have a load of lectures online about various things. You can find different lecturers explaining the same thing in a slightly different way, and then it will probably click in. But I think, yeah, just exposure to as much as you can, talk to as many people as you can that have that experience, is probably the main piece of advice.
100%. And yes, shout out to GeoHug because that's on YouTube and there is heaps of mining and geology content there. So
Yes,
get on that.
exactly.
Yeah. You'll get a whole huge overview. Yeah, 100%. What are some other tips on where people should go to try and get started?
Yeah, definitely. So yeah, I mentioned about learning how to code and picking a language. Another thing that you'll probably hear is a lot of people say, particularly with Python, they're like, oh, Python's easy. No, I don't think when you're learning something new that it is anything's really that easy. I think people are just trying to make themselves sound clever. But I would certainly say out of a lot of different languages, it has the most straightforward syntax if you are starting to learn. So yeah, that's definitely a good place to start. I would also say practice. So if you're not coding all the time, anything that you do remember and you learn, you can forget quite quickly. But I also think, and I certainly had this as well, that there's a bit of a misconception that once you know how to code, that you can just basically, you like sit in a dark room and you've got the matrix going up and down your screen and you're like hacking into CIA mainframe or something like that. To me, it's more about knowing not so much what to Google, but well, sometimes, but also how to understand that what comes back to you. So it's not about being able to just code out of your head. It's about knowing enough about it so that you can figure out how you want to do it. And then also when something goes wrong, understanding how to fix it. I think that's definitely part of it. And I would certainly say as well to try and go for the low-hanging fruit when you start off. Try and find something that's you know, interesting to you or is going to be useful to you that you can automate. So one example, a little script that I wrote recently was just about, you just give it a folder name, for example, run the script and it will print out, you know, what documents and what folders are within that. And you can get code can do that for you through command prompt with just a single line of code, but this formats it a little bit better so that you can at least kind of see what's going on within your folders and things. Really simple script, but I've just found it really useful because especially working for a consultancy, you're often given big packages of data and you've got all these nested folders and files. Run that script, takes less than a second, and you can immediately then pick out where you want to be looking for things. So yeah, either finding something that's interesting to you that you can automate, or something that takes a lot of time out your day that you're doing all the time. So it just gives you that context and you're doing something useful, or even something interesting. Like I always think if someone tells you that something is fun, if you need to be told it's fun, then it's probably not fun. But you can at least find something interesting that will mean that you're invested in it and you can enjoy it, and you get that sense of satisfaction when you finished it as well.
Yep.
Yeah.
Awesome. there's some awesome questions coming through in the chat. I'm about to open it up, but the last one from me was, I want to sort of get you to touch a bit on the ethical considerations. So like all of
Sure.
it,
Yeah.
privacy and that whole realm of things.
Yeah, that's definitely a big thing. I mean, the kind of traditionally just more general AI kind of concerns. Obviously, there's a lot of ethical considerations with things like facial recognition technology and stuff like that, which isn't necessarily relevant in the same way to mining and geoscience, but there's still, can be issues with it. So one of the things is bias, one of the big things. And so if, for example, like if you were doing something like an environmental impact assessment, say, and you've trained your data on a particular area, and then you apply it to a new area, and it doesn't, because of that inherent bias in the input data, it doesn't pick up the things that you need it to pick up in your new area, that can obviously cause problems. You miss stuff, basically. There's also the kind of environmental considerations as well, which I think are, quite important. So a lot of this stuff is run on cloud platforms. You've got three really main providers of that. You've got Google Cloud, AWS, which is Amazon Web Services, and Microsoft Azure. And they all use these data centers, which require huge amounts of water for cooling, all of the technology and stuff like that, and the power as well to run them. So there is a lot of concern about that generally too. And most of those big cloud providers are either giving themselves targets or are working towards targets to be carbon neutral by X year or what have you, or carbon offset or fully renewable powered. But it's definitely something to consider. And I actually had quite an interesting chat with an old colleague about this a few years ago, where he was saying to me, do you ever feel guilty about working in mining? And his job was like software development, cloud engineering, all of that kind of stuff. And I was like, well, do you feel guilty about that? Because there's still that consideration there. So I think the fact that these companies are trying to drive towards that sort of carbon neutrality is really all we can hope for at the moment, but it is something to bear in mind for sure. And then like the privacy data protection side,
I was
again,
curious about that, because there's like, obviously every company has like a lot of confidential geological data that they might not want to share.
Exactly. And it's a really good point with something like AI, where the more, I mean, quite often the more data, the better your model, but it does depend on the quality of the data. If you are dealing with, certainly from a consultancy background, you've got lots of different clients and different data. You can't use everybody's data to train a model, which you then go and use on someone else's work. So there's a lot of kind of, consideration that you need to get to have around that, and getting permission if you want to reuse data, or trying to build things on data that is publicly available and open source, that you can just use and then tweak maybe towards your particular target of what you're trying to achieve. But yes, it's definitely something that needs to be considered. In the UK, we have a law called GDPR, which came in relatively recently, about data protection, how you can use people's data. And I would imagine that that's, coming soon in other countries, if not already. So it's like if you go on a UK website, you've probably noticed you get the little thing popping up about cookies. That's all part of GDPR kind of data privacy laws. Yeah.
No, that's interesting. Well, thanks for that. I'm going to read out a few other questions that have come in on the chat, but everyone is like welcome to jump off mute now, ask your own questions, and we can keep the discussions rolling. But there was a good one here. There's a lot of different jargon in data science. How do you educate geologists? Well, I mean, there's a lot of jargon in geology. I barely understand half that language, but that's different. But how do we educate geologists with what terms such as feature engineering and
Yes. No, it's true. Like you said, it's like everything. Every field of work
has its own language.
jargon. Everyone wants to make themselves sound clever, and yeah. Or you just get used to using these terms and then you forget. So, I mean, I think maybe even just by sort of compiling a bit of a glossary where people have got a central location where they can look these terms up. And like when I started at the beginning, I was trying to sort of explain some of sort of how I see some of these terms. It can be quite subjective. So yeah, trying to kind of amalgamate that into a single source of truth can be quite a challenge. But I would say, yeah, if you can just document it, have somewhere to look things up, to explain what feature engineering is. Apologies for using that. That's effectively when you're kind of squeezing information out of data that you already have, or kind of massaging it into a form which might be more useful. So to give you a real example of that, if you look at, say, and going back to thinking about this river levels and flood prediction work that I was doing, at certain times of the year, in the winter, you get more rain. So you're going to have more, higher water levels in your rivers. So you've got like a cyclical pattern. So one feature engineering you can do with that is to basically, over the course of, say, a year, extract like a median or a mean for every month and use that as your input data rather than the raw data itself. And it kind of just, it's sort of about, I mean, that's just one example. There's lots of different types of feature engineering you can do, but yeah, that's basically what it is. It's just trying to squeeze your data into a form that's going to be more useful to your model at the end.
Yeah. Do you think AI is capable of automating report writing or pre-populating, say, for like compliance checks for JORC or the NI 43-101 reports?
Definitely. I think it certainly can. I mean, but in terms of getting it through those kind of legalities, if that's the right word, of getting it approved by everyone to do it is the next challenge. I think the capability is there, but the stage, of where that's accepted as an approach is maybe yet to come. But yes, it's certainly, ChatGPT is certainly good for helping write reports. I would just say be very careful about checking what it's given you, because it definitely makes mistakes. So yeah, just a word of caution really about using it. But it's certainly a useful tool. All of these things I see as useful tools rather than a replacement for what is an existing process.
Nick?
I can't help but dive in when you said that it can be used for report writing. I absolutely don't agree with that. I think it can for routine reports, but most of the reports that we do as geos are interpretive. And AI is great. I think it's a great tool, but and as you just said, it's simply a tool, and it doesn't interpret the data. And that's where I think I'm not bothered at all about. Now, mind you, I'm at the end of my career, so it doesn't really matter for me. But I don't believe that geos are going to be done out of jobs because of AI.
No, neither do I. I said that earlier.
A means of processing the data. And the interpretation's still got to be done by the human brain.
Of course it has. Yeah. Oh, for sure. No, it's definitely a tool, but it goes back to that sort of point of view, I suppose, of the context. There's definitely certain things that you can't do with it, but you might be able to, generate, for example, the section in your report that's about the regional geology, for example, or something like that as a starting point that you then kind of interpret, because that knowledge has come from general information that's out there that it's not specific to your deposit. And again, it's a tool, it's a starting point. So you can generate some text from that, but then you want to check it and you want to interpret it, like you said, and have that geo brain. So yeah, it's not going to, I suppose that the question was
going to write the whole report
how I
for
saw
you.
it was how to try and help with the report, not to generate a full end-to-end polished, finished product.
Okay. Fair enough. I just worry that we are, to my mind, it's a tool. It's fantastic for pattern recognition, which is a lot of what we do in exploration and so on. But in terms of the interpretation, it can't do that.
Oh, Definitely not. No, for sure. No, I 100% agree with you. Yeah, but yes, it is a
All right,
useful
fair
tool,
enough.
and there's certain bits that it can do. But
Yeah.
it won't write you a fully JORC compliant report, unfortunately.
No.
It would be nice.
It would be nice, yeah.
Yeah.
No, it wouldn't.
I
I
not that
don't
I
know.
mean I never do JORC. I know like that's not my world, but in general I don't like reports. So if
I
could do
enjoy
it
the
for me, I'd be
analysis,
really
but
happy
not so
about
much
that.
the writing.
Yeah.
Yeah, same.
What are your recommendations for dealing with missing data in a drill hole database where multi-element geochemistry is not complete for all samples?
Yes. So this, again, it kind of goes back to that context kind of thing, and also how much of your data is missing. So you could build a machine learning model that would actually fill those gaps for you more intelligently than, say, just like a linear interpolation or something like that. But depending on how much data you've got missing and how much data you have to train that algorithm would depend on how you approach that. Again, I'm not saying there's just not a sort of a set answer for every situation. If you only had a few rows of those of that data that's missing and you've got a lot of other data, then you could probably throw them out. But yeah, it's very context dependent. I would say there's certainly a place for using machine learning to predict those gaps, but also if it's your target element is the thing that you're predicting, you want to be really careful about that, because you don't want to, overinflate the bias or put something in there that's not actually real, depending on what you're going to do with it afterwards.
Yeah. Were there any other questions from anyone? You're welcome to jump off mute as well. I'll do another little round of promoting. Anyone that's an attendee, if you want to come up, you're more than welcome. But don't worry if you can't, it's fine. I don't take it personally. But if there's any other questions, please let me know. This has been really interesting. What are some, I've got one. So like you've mentioned a couple of different programs and things so far, but like what are some of your favorite products to use to help specifically with like geology and exploration?
I mean, it sort of also depends on what you have access to sometimes with the licensing for these things. But I did talk a bit about the Micromine CoPilot tool. I think that's really cool and really useful. From the point of view of just general coding, I tend to use Visual Studio Code. I'm familiar with it, and I think it's quite powerful, particularly if you're trying to deploy code in a product at the end as well. But it's very much a sort of a personal preference. And I know a lot of software these days, you can have that ability to interact with it using something like Python as well. So anything that allows you to do that, I'm a fan of, that allows you to tweak what you're trying to do to a specific, the specific thing you're trying to achieve, I think is really useful.
Yeah, awesome. Did you have another question, Nick?
Yeah.
Awesome.
Can you hear me? Yeah.
Yeah.
For me, AI is fantastic as pattern recognition, and it's brilliant. I think it's going to eliminate the subjectivity in core logging and chip logging and so on. And that's already happening these days. But everyone talks about prospectivity mapping and getting into actual target definition and that sort of thing. And I was involved in a workshop just recently, and we had a presentation on exactly this same subject. And I was asking, what is the difference between an AI prospectivity mapping, if you like, and it can be three-dimensional, which is a step forward, I suppose. But what's the difference between AI, the AI application, and regular 2D prospectivity mapping that we all do these days in a GIS? What are the fancier algorithms that you can use to improve the prospectivity?
Being able to process those huge amounts of data much quicker and also being able to generate different possibilities depending on what types of algorithms you're using. You can sometimes generate a probability associated with a particular outcome as well. So you can do that, you know, quite quickly, sort of just straight off the bat, and it will say, you know, there's this X% probability of something being here, for example. It's kind of having that and that processing power. So if you want to take, say, remote sensing imagery and stuff like that, being able to process that quickly. And also you can often build a tool that is then versatile and could be used in another area, depending on, you know, what you've trained it on and what you're looking for. So just that, that kind of ability to do something quickly and incorporate a lot more data. It doesn't mean, again, that the person doing it is not going to still give a really, you know, a good outcome. It's just a tool that can help you achieve that maybe a bit quicker and incorporate a bit more data as well, and different types of data to help you achieve that.
But you're still essentially just looking for areas of contiguous features or proximal features, and so there's nothing beyond that, is it? So basically it's just the same as we do in GIS, but with much bigger data sets and maybe many more.
I mean,
more data
like
sets.
I said before, I'm definitely not an expert on this. I haven't actually done this part of it myself, so there could be there probably is a lot more to it. But yeah, I mean, that's the main advantage as I see it, for that sort of thing. Sure.
How much faster, like obviously it depends how much data you've got, but like how much faster are we talking that it could speed up some of this stuff for you compared to doing it?
So like with, say, the Micromine CoPilot tool, so that's cloud hosted, so it sends it up to, I think it's Microsoft Azure, and runs the model and then sends it back to your machine. It depends, like you said, on the size of your deposit and stuff, but I mean, it's like, you know, half an hour or less if you, depending on your compute power, things like that. But if you were doing that manually as a person, that would take days, weeks possibly of work.
And the example that I was given in a recent workshop, the guys were doing prospectivity mapping across the whole of Australia, and the models were taking 10 days to run. So
the whole country. That's cool. Wow.
Kind of depends how you're using your algorithms as well, like what your sort of optimization parameters are with those. So you can let something run almost to the end of time, but you know, you kind of like optimize to the level of what you want your outcome to be. So you might accept that it's not going to be, you know, the improvement you get for running it for another week, say, is probably negligible. So then you stop it before it gets to that stage. So you have that kind of control and consideration you kind of build into it as well.
Yeah. Cool. Andrew.
Yeah, it's not directly related to geology, but I think there's also going to be some time savings in the future, particularly around the environmental, like ecology surveys and whatnot need to occur. So one of the coolest applications I've seen for AI is they've been flying drones over either landscape, or they're either looking for endangered or specific plant types, or they're looking for signs of animal life. And rather than sending someone out and walking the land, they're trying to get a very high level overview of particular species that might exist in the area. And it's pretty incredible, some of the results that are coming out of that. And I think there'll be a lot of time savings. There'll be a lot more data available for some of the reporting that's going to come out as well. And so I'm not sure if it'll result in overall time saving or if it will create more work, but very different results than what I was expecting. They've actually, I think MinRes released something last year where they actually found an endangered bird species on one of their tenements using AI. They're using it for all their closure planning now as well, and finding particular plants. So just seeing if their growth rates saying that the closure planning has been effective or not. So yeah, there's a pretty interesting use cases outside of just geology alone.
That's really cool.
Definitely. A friend of mine is doing a PhD at the moment on basically tracking elephant movements using AI and remote sensing data, which is kind of cool.
That'd be cool. I think that's it for the questions now. So thank you. That was really fun. I really enjoyed that. And yeah, can't thank you enough for taking the time, especially first thing in the morning over there. So
Oh, it's all good. Oh, it's 8 o'clock now, so yeah, it's not
Yeah.
too early.
yeah, no, this was awesome. Thank you. Thanks so much, everybody.
Thank you all. Take care. Bye.
Bye.